For the next 3 weeks, we're going to be talking about circles. You want to have your preview video notes out, please? Please write down both the location that you are watching this video as well as the date and time. Also, you need to turn off all distractions for the next 20 minutes, including please have your cell phone out of sight, out of mind. Please turn off both your Facebook, Twitter, YouTube, and video games and anything else that you may attempt to be multitasking and doing this at the same time. This first lesson, before we have our first lesson, we're going to do a quick review here, a quick review. We just finished talking about quadrilaterals. And so we're going to do a problem reviewing quadrilaterals. We have here a quadrilateral ABCD. We're going to graph that. A is at -3, 3. That's A at -3, 3. B is at 1, 5. C is at 4, -1. And D is at 1, -5. We're asked to define what kind of quadrilateral this is. Well, let's ask ourselves, when you have quads, there's three main families. There's the parallelogram family, parallelogram. And underneath that, we also have, under the parallelogram, that includes both rectangles, rhombi, and squares. And then we have the trap family, which includes isosceles traps as well. And then the third, you have the kite family, which stands alone in itself. So we're going to test to first see if it's in the parallelogram family. If it is in the parallelogram family, there's some additional calculations we need to do. To see if it's in the parallelogram family, we need to see if opposite sides are parallel. Opposite sides are parallel. That would be the basic definition of a parallelogram. So step number one, we're just going to quickly test the slope of everything. So we're going to find the slope first here of A to D. And slope is y minus y over x minus x, rise over run. So A to D slope is going to be 3 minus -5 and -3 minus 1. That's right here. This is A to D. And I end up with positive 8 over -4, which gives me -2. That's A to D. Now we're going to try the other green, which is B to C. And we're going to do here 5 minus -1 and 1 minus 4. And we see here this is going to be 6, positive 6 over -3, and again we get -2. So we know at least these sides are parallel. Now let's check the other two. We're going to go A to B, which in this case is the purple, and we're going to go 3 minus 5 over -3 minus 1. This is going to be -2 over -4, which is positive 1/2. And then let's try D to C. Again, y minus y, -5 minus -1. And then 1 minus 4, that becomes positive. That's going to be -4 over -3, that's positive 4 over 3. We can see that the purples are not parallel, so that lets go of the parallelogram family tree, because in order to qualify as a parallelogram, you have to have opposite sides, 2 pairs which are parallel. We only have 1 pair of parallel sides, so this qualifies only as a trapezoid. Now let's move along to circles. For circles, today's lesson is all simply about vocabulary. So I'd like you to do is actually pause the video here at this point, and let's see, I would like to the best of your ability to take all 8 of these vocabularies and attempt to draw it on the circle and label to the best of your own ability. Some of these terms you might be familiar with, and it would be interesting to test yourself ahead of time to see what you already know and remember. So at this point, pause the video, attempt to label those 8 items or any of them that you do know, and then come back. All right, let's see what you remembered. First off, very simply, when we talk about a circle, we're talking about the physical circle itself. We would call this the circle. Later on, we're going to be talking about specifically the length going around the circle, and we're going to call that length a circumference. The center of the circle, of course, is just a dot. Interesting to note, when we name the center of a circle, we name it by whatever point is at the dot. So if I put a Q here, I would call this circle. We would call this circle Q. We name circles by the center. And the symbol for circle Q would be a little baby circle with a center on it. Q. So we call that circle Q. The radius is any segment that connects from the circle from the center to the circle's edge. That would be a radius. This would be a radius. This would be, think of it as a spoke in a wheel. Something really simple you need to understand is that all radii are congruent. All radii are congruent, just like a spoke in the wheel. A diameter is simply 2 radii together. 2 radii together. So this would be all the way across. That would be a diameter. That green would be a diameter. Notice the diameter connects 2 points on the circle. 2 points on the circle. So diameter is actually also a chord. A chord is any segment that connects 2 points on a circle. The diameter is a chord that goes through the circle's center. But any segment that connects 2 points on the circle is called a chord. So this would be a chord. Connects any 2 points on the circle. Tangent goes through a single point on the circle. So if we have a single point, this line here, let's call this line M. Line M would be considered a tangent. Line M would be considered a tangent. And this point right here, if we call that a point, let's call that point P, we would call that a point of tangency. Point of tangency. So we've talked about a radius, talked about a diameter, talked about a chord, talked about a tangent, a point of tangency, and the last one is a secant. A secant is any line that goes through the circle at 2 points. So right here, any line that goes through the circle at 2 points, that would be a secant. Goes through the circle at 2 points. That orange right there is a secant. Knowing that vocabulary, come over here to page 4. What I'd like you to do is go through and pause the video and attempt to name one of each of these with this diagram above. Pause the video, name it, and come back. All right, welcome back. Let's see how you did. Okay, so if we were to name this circle, remember I told you that you name circles by their center. So we would call this circle A, or the symbol would be circle A. A radius, there's several of them. A to F would be a radius. Also A to H. Notice both segments start in the center. A diameter would be one that goes all the way across, so H to F would be a diameter. A chord would be any segment that connects any 2 points on the circle. So DG would be a chord. Also C to D. Notice I have endpoints there, not lines. C to D would be considered a chord as well. A tangent, you find a single line that connects at a single point. So a tangent here would be this purple. That point of tangency would be point here. H would be the point of tangency. We would call that tangent BH, the line, or you could call it HJ, the line, or you can call it BJ, the line. Remember, you only need, but that's a line, you only need 2 points to make a line, so you can name it all 3 there. A secant would be any line that goes through 2 points. So in this case, the secant includes that chord, so that orange now is considered the secant. So we're going to call that secant BD. Notice the arrows means it goes all the way through. We technically could call that also CD, but it's a line meaning it goes through. So be very careful. CD with the arrows would be a secant because it goes through. CD with the segment would be a chord because it would stop on those endpoints. Let's talk about some additional terminology. There's relationships between circles that you should be familiar with. There's 4 of them. These 4 relationships. Circles intersect. This would show intersecting circles. Intersecting circles. So we would call this a point of intersection. Circles that touch either outside or inside would be called tangent circles. These are called tangent circles. You could also draw them like so. If you had this and that point in which they touch but do not overlap, that, of course, is called a point of tangency. Circles one inside the other exactly at the same distance from the center all the way exactly. Those would be considered concentric circles. And circles which have the same length of radii, where the radii is exactly congruent, we would call those congruent circles. So that's relationships between or within circles. Relationships between or within circles. Or relationships between circles. Now we have a relationships within circles. And there are 4 key terms. These will be the last key terms that we need for this lesson. And the key terms are first the minor arc. A minor arc is simply a piece of a circle less than 180 degrees. So it would be a piece of a circle less than 180 degrees. So in this case, we would say the piece of the circle here, B to C, that would be considered an arc. It would be considered specifically a minor arc. So we would call it like this. BC, notice there's only 2 letters, and it's under 180 degrees. Now, if we actually knew the measure of the arc, let's say we knew that the actual measure of the arc was 60 degrees, we would represent the measure of the arc like this. Put a little m in front of it, we would say BC with the arc symbol. They would use an equal sign, and we would say 60. That gives what's called the measure of the arc, the measure, the degree measure. Now, a major arc is a piece of an arc as well. It's a piece of a circle, which is greater than 180. That's why it's called major. Greater than 180. So in this case, if we were to start at B, I'd like you to physically sweep. Put your pencil on B. Now physically sweep around the edge of the circle. Follow. Go through D all the way to C. Because that's bigger than 180, that's considered a major arc. And we designate major arcs using 3 letters. So we would call that BDC. Notice there's 3 letters there. We could go the other way as well, CDB. That would be a major arc. And in this case, since circles add up to 360 degrees, if we want the actual measure of the arc, we would simply minus that 60 degrees, and we would say the measure of the major arc is 300 degrees, and we'd represent it like this. The measure of, the little m there, BDC, put the arc there, equals 300. BDC equals 300. That is a major arc. A semicircle means exactly half a circle. Half of a circle. Degree-wise, that's of course always going to be 180 degrees. We use 3 letters for a semicircle, just like a major arc. So that would be one semicircle. This would be another using this circle. So I would designate the semicircle EHG, or over here I could go E through J to G. Notice you have to use 3 letters. Semicircles are half a circle. You must use 3 letters. And the last term you need to be familiar with is something called a central angle. A central angle is the angle that's connected to the center. And in this case, the center is A. So a central angle is an angle with vertex on the center of the circle. In this case, it would be angle A here, so we would call a central angle BAC, or we would say it's CAB. Either way, we could go like this. BAC, trace it, or you can go this way, CAB, trace it. But it's connected to the center of the circle. There's 2 key things you need to remember about the terms you just learned. The first one is this. Whatever the measure of the arc is, from our previous example we used 60 degrees, the central angle has the same measure, 60 degrees. The way we remember that is this measure of a central angle to its arc the same. Notice there's little notes around it. This is the beginning of a song that you're going to be using to memorize in this chapter. It goes like this. Measure of a central angle to its arc the same. Please pause, take a moment, and sing with me. Measure of a central angle to its arc the same. The next one you need to know is that if you have congruent angles, central angles, congruent angles, if you have congruent angles, we're talking specifically about the central angles, then you also have congruent arcs. If you have congruent angles, then you also have congruent arcs, and vice versa. Last one you need to be familiar with is that if you have adjacent arcs, That means arcs that are next to each other, then you can add them. For example, here we have arc DA and arc AE. We can add them like so. For example, we can say the measure of arc DA, notice the little m in front of it means measure of the degrees, plus the measure of the arc A to E, notice again the little m with the equal sign, that means measure of, equals the larger arc, and in this case it's a semicircle, so we're going to use 3 measures DAE. Little arcs add up to big arcs. Little arcs add up to big arcs. With that understanding, let's try this problem. I'm going to read. It says in the diagram below, EB is a diameter, AF, AD, and AC are all radii. The measure of angle FAB is 60 and BAC is 52. Find all possible arc and angle measures. Let's take a moment and mark these. It says in the diagram below, EB is a diameter. Whenever you see the word diameter, immediately drag it out beyond the edge of the circle. So here's EB. Always drag it out beyond the edge of the circle. Diameters, drag. Diameters, drag. There's a reason for that. Diameters, drag. Say that out loud. Diameters, drag. The reason why is the minute you have a diameter, I'd like you to automatically sweep the 180 and sweep the 180, because diameters split circles in half, 180 and 180. I'm going to read and cross out. AS, AD, and AC are all radii, so I'm going to trace them. AS, AC, and AD are all radii, and out of habit, always mark radii congruent. Trace and mark all radii congruent because they are. They're spokes in a wheel. The measure of FAB is 60, so we're going to do this. FAB, trace it. Start at F. Go to A, trace it with me. B, sweep. We're told it's 60 degrees. And next, BAC is 52. So start at B, go to A, go to C, sweep, 52. Find all possible arcs and angle measures. I'd like you to pause the video at this moment, take about 2 minutes, and try to find yourself all possible arcs and angle measures. Then turn on the video again and check your answers. Let's see how you did. First and most important is measure of a central angle to its arc the same. So if this is 60, this arc is 60. If this is 52, this arc is 52 as well. Now, because of the 180, hopefully you spotted that. That's why I had you drag diameters out. You should be able to find this arc measure right there, which of course is 120. Notice here you have a 90 degree. Hopefully you spotted that, which means this is 90 degrees. And then going this way, we also have 180. So we add 52 plus 90. And we're going to take that away from 180. And of course we get 38. So this angle right here is 38, which means this right here is 38. So now you can see how you can find all the arcs and angle measures using measure of a central angle to its arc the same, and then using the diameters as well.